So very, very important. Nucleophilic substitution reaction. What do you mean by nucleophilic substitution reaction? Very, very simple, very, very easy manner I'll explain. Concentrate. So first important point, nucleophilic substitution reaction, NSR. Nucleophilic substitution reaction, NSR, takes place generally in halogen compounds. Generally in halogen compounds. What is substitution? One of the nucleophile you see, halogen. In the place of halogen, the nucleophile is substituted. In the place of one atom, another atom is substituted. Here nucleophile is substituted in the place of X. Therefore it is nucleophilic substitution reaction. Generally, this mechanism takes place in two ways. The first one we are calling SN1, second one we are calling SN2. What do you mean by SN1? S for substitution, nucleophilic, unimolecular. Otherwise we can say like this, unimolecular, nucleophilic substitution reaction. SN2, substitution, nucleophilic, bimolecular. We can say SN2, bimolecular, nucleophilic substitution reaction. Anything is correct, nothing to worry. So today's class, let us discuss the first one, SN1. We are discussing about SN1. SN1, nucleophilic substitution in unimolecular reactions. So generally SN1 takes place in tertiary alkyl halides. The mechanism is taking place in two steps. Very, very important. In first step is slow step. Also we are calling rate determining step. Why it is a slow step? We are converting the sp3 carbon, all sigma bonds, into unstable carbocation. The stable sigma bonds we are converting into sp3, we are converting into sp2. That is the reason slow step, rate determining step. In first step we are getting carbocation. Second step, fast step, attack of nucleophile, we are getting finally product. So what are the properties, characteristics of the SN1? The mechanism takes place in two steps. And very, very important, the rate is directly proportional to only the concentration of alkyl halide. And rate does not depend on the concentration of nucleophile. This is very, very important. In SN1 reaction, if question is framed like this, concentration of alkyl halide and nucleophile increased 2 times, rate of reaction is. So already I told you rate is directly proportional to only concentration of alkyl halide. Therefore, when concentration is increased 2 times, rate of reaction also increased by only 2 times. So it does not depend on the concentration of nucleophile. Carbocation is intermediate. Concentrate beta. Carbocation is intermediate. Whenever carbocation is there, rearrangement possible. Rearrangement may be hydride shift, maybe methyl shift, maybe phenyl shift, etc. So rearrangement is possible. Next one is, let us discuss SN1 reaction is favored by polar protic solvents. PP, polar protic solvent. Only one alphabet is there, that is the reason it is SN1. Whereas polar aprotic solvent, we have 2 alphabets, therefore it is favorable for SN2 mechanism. Polar protic SN1. polar aprotic SN2. So polar protic means which ready to give protons, which ready to donate H plus ions. So first important point, it is taking place in tertiary alkyl halides. Mechanism is taking place in 2 steps and rate directly proportional to only concentration of alkyl halide. Therefore, it is an example of first order reaction. First order reaction. And in rate determining step, RDS step, only alkyl halide is participating. Therefore, it is an example of unimolecular reaction. Example of unimolecular reaction. And polar protic solvent will favor SN1 mechanism. SN1 mechanism. Let us discuss the stereochemistry, which is very, very important. We are taking tertiary alkyl halide. If you take this carbon, it is a chiral center. Carbon attached with 4 different groups. A tetrahedral atom attached with 4 different groups we are calling chiral center. If chiral center is there, already we discussed, we are getting carbocation in first step. The nucleophile can attack from front side as well as from back side or rear side. If the nucleophile is coming from the front side, we are calling retention product. If it is coming from back side, we are calling inversion product. So generally around 47% we are getting retention, 53% we are getting inversion product. Very, very important. 100% it's not racemic mixture. Inversion dominates over retention. Very, 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 very important beta. In SN1 reaction, racemic mixture is expected, but inversion product dominates. Hence, it shows partial racemization, not 100% racemization. Very, very, very important beta. This is very, very important point. You have to remember. Very, 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 very important point. Very important point. So we'll get racemic mixture. If chiral carbon is present. If chiral carbon is not present, there is no racemization. And more stable carbocation, more is the rate of reaction towards SN1. Very, very important. So finally, the reactivity of SN1 reaction. Reactivity of SN1 is directly proportional to the stability of carbocation. Remember, benzyl, allyl, tertiary, secondary, primary. Benzyl, allyl, tertiary, secondary, primary. And better leaving group will increase the rate of SN1. Alkyl iodide is the best leaving group compared with alkyl chloride and fluoride because of large size. Whereas very, very important, halogen attached with sp carbon, sp2 carbon, halogen attached to sp carbon or sp2 carbon or bridged head does not undergo nucleophilic substitution reaction. Both SN1 as well as SN2. This is bridged head. This is aryl. This is vinyl. Does not take place SN1. So finally, what we have to remember, dear? SN1, you have to remember tertiary alkyl halide. Stable carbocation, polar protic solvent. Tertiary alkyl halide, stable carbocation, polar protic solvent. So question you see, SN1 reaction, compare the rate of SN1. This will be primary, this will be ethyl, this will be secondary, this will be tertiary. So therefore, very important, this will be more reactive towards SN1. Next example I am taking, this is minus M, this will be hyperconjugation, this will be plus M, this will be plus M. So therefore, stability of carbocation directly proportional to plus M plus H plus I, inversely proportional to minus M minus I. So therefore D is more reactive than C and then B and A. This is the order of reactivity towards SN1. So thank you one and all. Like the video and share the video. Thank you. In the next class we'll discuss SN2 mechanism.